Hello, welcome to your lesson on the nth term of an arithmetic sequence. Pretty big idea in math. Sequences, and especially these kinds of sequences, will follow you all the way through calculus and beyond. Let's take some notes. Please use the notes page that has been provided to you. It's a two-page stapled packet. We'll just be doing notes on parts of it and save this packet for upcoming lessons. You're going to keep adding to it. All right, so the packet begins with this page here, but we're only going to do the left side here. It's titled Two Important Types of Sequences. All right, so let's zoom in on this part on the left. One important type of sequence is called an arithmetic sequence, a sequence with a common difference between successive terms. You'll see what that means in a moment, but this is the main definition of what an arithmetic sequence is. So if you look at these numbers here, you'll notice this is 9, 7, 5, 3. If you look at the difference between these two numbers, you go minus 2 again, minus 2 again, and you'll keep subtracting 2. There's a pattern there. So if you subtract 2 again, you'll get a 1, subtract 2 again, you'll get negative 1, and then subtract 2 again, get negative 3. This is called an arithmetic sequence. It has the same number, same difference between all the terms. So we're going to use the letter D to represent this common difference, and in this case, the common difference is negative 2. So that's the common difference part of what an arithmetic sequence is. Let's look at this one. Does it do the same thing? 3 to 4.5. Well, we're adding 1.5. And then here, adding 1.5 again. And 6 to 7.5, adding 1.5 again. So we keep adding 1.5, we get 9, then 10.5, then 12. This is also arithmetic because we have a common difference between terms. We're always adding the same amount. So the D value in this case is 1.5. Okay, those are arithmetic sequences. So based on that definition, let's graph it and see what it looks like. So here we're going to have n is the position. So here on the x-axis, on the horizontal axis, we're going to have the position of the term. So at position 1, we have 3 in the sequence. At position 2, we have 7 in the sequence. At position 3, we have 11. So here's our sequence. If you notice, this goes up by 4, and then 4 again, 4 again. So the next one's going to be 19, then up 4, 23, up 4 again, 27. So the sequence has a common difference of 4. It's going up by 4 every time. There it is. All right, now we're going to graph it. So at position 1, it was a 3, so that point is right there. At position 2, it was 7, so that point is there. At position 3, it's 11, and so on and so on. Please continue adding the points. And what do you notice? We go all the way here up to position 7 is 27 in the sequence. What do you notice about those points? Well, they are linear. They make a line, basically. We're just going to keep them as separate points because those are the actual numbers in the sequence. There's no numbers in between, but you'll notice they do line up in a perfect straight line. So the conclusion here is arithmetic sequences are always linear. And the common difference is like your slope. All right, so look at these on the bottom of your page, and the question is, which are arithmetic? So you take a look at these and decide which are arithmetic. So first one, yes or no? Well, adding 4, oh, adding 6, adding 6. So there wasn't, it seemed to have a pattern, but then it changed. So there's no common difference, so it's not arithmetic. Next one. Add 6, add 6, add 6. All right, from what we see, it does have a common difference. The common difference, D value is 6, therefore it's arithmetic. Next one. Minus 3, minus 3, minus 3, minus 3. From what it has shown us in the sequence, there is a pattern. Common difference is negative 3, therefore it is arithmetic. All right, the goal today is to find the rule. What is a rule for any arithmetic sequence? So here's an arithmetic sequence. You can see that there's 2 coins or 2 circles there, and then there's 5 in total, and then there's 8 in total. So the red actually shows how much has been added each time. To go from 2 to 5, we've added 3 extra. To go from 5 to 8, we've added 3 extra. To go from 8 to 11, also added 3 extra. So it's always an extra 3. So the D value here, since we're adding 3 every time, the D value is 3. So this is definitely arithmetic. Now let's think about what a general rule for this arithmetic sequence would be. Like if we were looking for term number 100 or term number 50 or 50,000 even, how could we find it? We could use a rule to find it. So to find the second term, you'll notice that you take u1 and you add the difference, right? You take u1 and you add 3 and then you get the second term. So that's how you get the second term. Now to get the third term, u3, to get this term, u3 is 8, we start with u1 and we add the common difference once and twice. So we have u1, which is 2, plus 2 times the common difference gets us to 8. So let's continue that pattern. u4, the fourth term is 11. To get to the fourth term, we can start with u1, which is 2, and we can add the common difference how many times? Once, twice, 3 times. So we start with u1 and we add the common difference 3 times, and we get the fourth term. So what would this rule look like here for the fifth term, which is 14? Can you write a similar rule? So for u5, we take the first term and we add the common difference, but how many times? Well, to go from here to here, we add the common difference 1, 2, 3, 4 times. So to jump from the first term to the fifth term, we take u1 plus the common difference 4 times. There's 4 3's we add to get there. You should notice a pattern here. All right, when we need u2, we have 1d added to u1. When we need u3, we have 2d. When we have u4, we add 3d. When we have u5, we add 4d. Notice this number is always 1 less than this number. So to get un representing some mysterious future term, we don't know which, it could be any term. To get any future term, we take u1 and we add some number of d values, and we always add a number of d values that is 1 less than the term we're at. And the reason for that is, for example, here when we got to u5, how many jumps are from u1 to u5? Well, to get from u1 to u5, there's not 5 jumps, there's actually only 2, 3, 4 jumps. So 4 3's, right? We're always adding 1 less d value to get from u1 to the one we need. So to get to un, we take u1 plus how many jumps to d? N minus 1. So if this was 10, this would be 9. If this was 11, this would be 10. If this was 20, this would be 19, right? This number of jumps is always 1 less than that. So there's our rule. That's our general rule. So on back to your notes page, there's a page that says sequences in series formula page. We're going to just look at the first of the 4 boxes there. We're going to look at the first one, the nth term in a sequence, and this is for arithmetic sequence, and the formula is here. So basically for this whole unit, you have to know 4 main formulas, and this is one of the 4 here. How to find the nth term in an arithmetic sequence. So there's the formula. Here's an example that we're going to solve using that formula. Here's the sequence. Again, that is the same arithmetic sequence we just saw. It's going up by 3 every time, so d value is 3. So we need to find the 10th term and the 25th term. So we're going to use this formula that we just created. To find the 10th term, u10, we're going to say u1 plus n minus 1 times d. So u1 is 2, the first term, plus n minus 1, which is 10 minus 1 in this case. We're going to 10th term, so n is 10. 10 minus 1 times d. And that ends up being u1 plus 9 times 3. Because again, to get to the 10th term, we start the first term, we do 9 jumps of 3, and then we get to the 10th term. So that 3 times 9 is 27, and we find out that the 10th term is 29. So that's how you use that formula. That formula is used anytime we need any future term in an arithmetic sequence. So now try to find the 25th term. So figure that out. All right, and you can check your work here. So in u25, we put u1 here, and then 25 minus 1 times 3, and that should work out to 74. Okay, just a couple more examples. These ones are on the attached page, which is the practice problem page. Again, we're looking at arithmetic sequences and the nth term formula. Here's the first problem you see. It says the second term of an arithmetic sequence is 1, and the 7th term is 26. Find the first term and the common difference. So first of all, looking at what it gives us, it tells us the second term is 1, 7th term is 26. It's actually telling us 2 different statements. It's saying the second term and it's giving us also the 7th term. So I'm going to write the equation for the second term. So that u2 equals u1 plus n minus 1, so 2 minus 1 times d. We don't know other pieces here. We do know what u2 says. The second term is 1, so I'm going to replace this u2 with 1. So 1 equals u1 plus d, because this is 2 minus 1. All right. Then I'm going to write a separate equation for this second bit it tells us, which is the 7th term is 26. So I'm going to write u7, which is u1 plus 7 minus 1 times d, using our formula. And we know the 7th term is 26. So I'm going to replace this u7 with 26 right here. And this simplifies to 6d. So now we have two equations. This one for the second term, this one for the 7th term. And notice these two equations are two equations with the same unknowns, u1 and d here. So this is basically a system of equations. We can solve it by substitution or elimination. I think substitution in this case is easy. I'm going to take this one and I'm going to solve for u1. To solve this for u1, I took that d, I moved it over there, so I end up with u1 equals 1 minus d. And now I'm going to take this one, this second equation, I'm going to substitute that into there. So that u1 right here will be replaced with this. So notice 26 and then 1 minus d has replaced the u1. And now we have an equation in one variable. We can solve that. So combine minus d and 6d to get 5d. And then solve that. Minus 1 divided by 5, you get d equals 5. And once you know d is 5, you put that in here, you can solve for u1, and u1 is negative 4. So basically this created a system of equations which we then solved by substitution, and we got our answers for d and u1. Now that you know d is 5, u1 is negative 4, you can find the 100th term. So try that using our formula. So here's the work for that one. So now we know, again, d is 5, u1 is 4, and if you plug it in here to find u100 is u1 plus n minus 1, which is 99d. Solve that, 491. All right, and the last problem, here's a sequence with these numbers. Let's double check its arithmetic first of all. 6 and 10, 14. So this goes up by 4, up by 4. Okay, so there seems to be a common difference of 4. So part A says, what is the common difference? D equals 4. And then it goes dot, 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 50. So eventually this sequence gets to 50. And our goal in B is to find the number of terms in the sequence. So it means this is term 1, term 2, term 3. And then this is, what term is this? Term number 20? Is it term number 30? Well, I guess you could keep adding 4 here and get to 50 pretty quickly. That's a quick way to check. But let's say this number was much bigger. How can we use our formulas to actually figure out what term number this is? So let's use the formula. Un equals u1 plus n minus 1 times d, our general formula. And in there, we can plug in what we know. We know un, some future value, or in the sequence, is 50. So I'm going to replace that with 50. u1 we know is the first term, 6. And d value we know is 4 because it goes up by 4 every time. We don't know n, however. We don't know what term number produces this 50 in the sequence. And that's what we're going to find, what term number. So solve this now and see what term number produces 50 as the number in the sequence. Okay, when you solve that, I multiplied this 4 through here, 4n minus 4. Then I'm going to combine the 6 and negative 4 to get 2. And then solving that, minus 2 divided by 4, get n is 12. So what that tells us is that this is the 12th term in the sequence, and the 12th term. So this, if you put a 12 back in here, or back in here, it would work out. 12th term is 50. If you continue this, adding 4, adding 4, adding 4, you get to 50 on the 12th term. All right. Please complete the practice assignment. You'll see it linked on the website. There's more problems very similar to the ones you just saw in the video. So practice until you feel confident. Practice any problems, and make sure you have any questions that you put in the Padlet. Make sure you ask anything you need help with.